I am working out problem 79 in chapter 3, and this problem is asking me for the velocity of the truck relative to the car. And this question is telling me a car is driving directly north, 10 kilometers per hour, and then a truck is exiting from the interstate. It's going northwest at 85 kilometers per hour. And when those two tails meet right there, the angle formed is 35 degrees. So I know my velocity of the car, velocity of the truck, and angle of theta. I worked the problem out beforehand. Since they're asking for the velocity of the truck relative to the car, I'm going to focus on the truck. So in order to find this, I'm looking for the x component and the y components. First, I did my y components. F of y equals sum of all x. F of y equals 0. F of y equals velocity times cosine theta. My velocity of the truck is 85 kilometers per hour times cosine of 35 degrees is which they give me. And then I end up with 69.63 kilometers per hour for my y. And for my x components, I have sum of all f of x equals 0. And f of x equals velocity times cosine of theta. My velocity of the truck is 85 kilometers per hour times sine of 35 degrees. This equals 48.75 kilometers per hour. The reason why y component is cosine is because it's adjacent to the angle. The reason why x component is sine because x component is opposite to the angle. And then for me to find the relative velocity, I would have to use the Pythagorean theorem, which is the formula here. I'd plug in my x and my y's, and then I just plug it in the calculator, and my relative velocity that they're asking for is 63.3 kilometers. So 63.3 is the velocity of the truck relative to the car. The next problem I have is problem 106 in the textbook, same chapter. It's telling me that there's a rocket that's launched from rest from Earth going on above Earth's surface straight up. And then they give me the time of 8 minutes, displacement of 160 kilometers, and velocity of 7.6 kilometers per second. We usually like seconds, meters, and meters per second. So I did my conversions right there. 1 minute equals 60 seconds. Multiplied that, got 480 seconds. Kilometers to meters. I did that and got 160,000 meters. And then I did for kilometers per second, I converted to 7,600 meters per second. My average velocity is change of distance over change of time. Displacement was given 160,000 meters divided by 400 seconds, which gives me 333 meters per second. So that is my change of velocity. Not my change of velocity. That's my average velocity that I was looking for. And now they ask for the average acceleration. This is the equation of delta V over delta T, change in velocity over change in time. And then they give me velocity and time. I just plug it in. 7,600 meters per second divided by 480 seconds, which gives me the average acceleration of 15.8 meters per second squared. And that is it for the equation.